Yeah. All right, guys. We're going to take a look at a groundwater simulator today. And as we look at it, we're going to take a look at the different aspects of it. First of all, we need to find the potentiometric surface. You know, what's the hydraulic head? Well, up here we have a recharge area, and it's a little bit wet into there. If you follow it, you can sort of see that there's water here, there's a little bit of water in the lake, and then there's some in the river. So the potentiometric surface, or the water table in this case, drops from here, the high, to here, the low. Okay? More pressure here, less pressure there. Those are the things that we've been looking at in the classroom. Okay? So we can do a couple things here. The river is flowing out someplace, and I can actually dam up the flow, and so we can make the river rise, or we can let the river, flow back out like it's supposed to. Now, in this simulator, one of the things that we're seeing is that this has got some clay, some sand, some coarse gravel. It has a confined aquifer with a aquitard. It has an aquiclude. Aquitard allows some water to go through. Aquicludes don't allow any water to go through. But you have fractured bedrock, which could be a cavern or karst system as well. So what happens when certain aspects are polluted? I hope that thing's running. All right, so let's do a little pollution here. And what I'm going to do is, in the septic tank, I'm going to put a little food coloring or dye, and I think green ought to be a good color for that. We'll put a little green color in the tank there. Now let's take a little watch for it, just a few minutes, and see what's going on. Just look at it and see. Now, so this is supposedly a person who has not maintained their septic tank very well. We can see the pollution plume. Kind of like what you guys did the other day when you mapped the plume of material coming off the gas station. Well, this is I guess a better simulator in some ways, because we can see, yeah, it's already in the lake, isn't it? All right. While we're talking about the gas station thing that we did the other day, we can look at, suppose we do have a leaky underground storage tank, a gas, either from a gas station or from your household oil storage, if you happen to have oil. Yeah, a lot of people don't use oil anymore, but some people do.
Walk to the lake.
Yeah, the lake's pretty well polluted from the septic tank right now. And do we see it coming out anyplace else?
So it's going all the way over to the...
Going all the way.
Yeah.
It is going to all the way to the river?
Yeah.
Yeah, it should eventually go to the river. So let's take a look at let's watch it for a few minutes and see what happens. Yeah, it's already coming out of the springs, and it's already in the river. So the septic tank happened pretty quickly. It moved very fast. The
gas is...
underground storage tank, yeah, it's dropping quite a bit more. I'm not sure that's totally accurate, because oil typically is less dense than water, so it might have a tendency to ride up a little bit higher, but still, this is the way the simulator is working right now. Okay, what would happen though if I took and pumped well 2 very, very rapidly?
It's gonna suck it up.
Yeah, it's your cone of depression, right? The down draw would create a cone of depression, and we should be able to reverse this pollution plume. Suck it up, man.
Well, maybe.
I can see from my down draw here that I'm starting to get pollution. Okay? So that really, I think, emphasizes the down draw and the cone of depression that we were talking about in class. You can even see that V shape. I'm not sure whether it shows up very clearly. I don't think it does, but you can see that it reversed the pressure gradient. And that created a big problem, we see. At least if this was a real land and people there, because this person's well just got polluted. Did this well get polluted or that well get polluted? Well, no. And maybe we would expect it to get polluted, but it didn't seem to.
Hey,
I'm going to put a little bit more red in the tank because it's running low.
put
Just a
some in the
little
bottom.
bit. What?
Put some in the bottom.
Oh, I'm going to do that. Yeah, I'll put some in there. How? We talked about karst and karst topography and also fractured bedrock, which is just what we see in this simulator here. It's called fractured bedrock, but it could be caves. They're pretty much open to flow, right? So how fast, let's suppose that well number 1 was a sinkhole, and somebody decided that they were going to just dump some stuff down a sinkhole, or maybe there was a spill and that water ran off into the sinkhole. Maybe a gas tanker truck overturned on the highway and the material just flowed right out, and of course the sinkholes are downhill, so it flowed down into the sinkhole. How long does it take to pollute?
Not long.
Uh-uh.
Maybe a minute. Or a day. Theoretically.
Or hardly any time
Just
at all?
now.
Yeah,
Good Lord. It's already in the river.
already in the river?
Yeah.
Yeah, so it's really quick when you're talking about a cave system or fractured bedrock system.
Just because of the pressure?
And well, there's a high potentiometric pressure here, and it's low here, and this is pretty much all open space. It's a very large pore space. So we've already polluted this well. The other couple wells aren't polluted because they're also within different aquifers. This one is polluted with the red and the green, but it's in a unconfined aquifer. This guy's in a confined or semi-confined aquifer because there is some material can get through. We see that the aquiclude or the aquitard is preventing some of the pollution from going through, not all of it. But yeah, the river is now pretty nasty. It's got
That's why you don't need fish out of the river.
it's right when you fish out of the Shenandoah. That's right, because of all the pollution and stuff in it.
What exactly is a sinkhole? I mean, I know it is what it
Okay,
says,
well,
but
when we were doing it, when we were looking at it in class, a sinkhole is basically just a
Depression?
cave system that part of the roof of the cave is collapsed, and so it's a depression that is a conduit to the cave system. It might be an open conduit, in which case it's called a window, or it might be that it's just a depression with some mud and clay and soil and stuff and rocks, and it may even have a pond in it when it's wet, but then as it dries up, the pond will actually seep through and into the cave below. So it is an opening into the cave system. It's just a matter of how fast that opening is. It could be draining opening where it's just everything just goes right straight down, or it could be a slow seeping opening. Not quite as slow as say the groundwater or the when you have the soil moisture. I'm sorry, that gets used up by the plant roots, and not very much of it makes it into the water table and to the aquifer itself. So let's take a couple quick looks here. I'm going to walk in front here. So we have the water table we can see is here. Everything below is considered an aquifer. The aquifer, of course, is something that contains water. Now, we decided that an aquifer had to be able to be porous, permeable, and potable. I don't think I'd want to drink any of this stuff now, so potable is maybe out of the question. But it still is groundwater, either way, whether it's an aquifer or not. The definition for aquifer being potable is questionable in my mind from a geologic standpoint, but from a civil engineering standpoint, yeah, it is it has to be potable in order for it to be a viable aquifer.
The ocean's polluted.
Yeah, the ocean back here is very, 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 very polluted. So we could see this. Let's pump a few other wells and see what happens. Which well should I pump?
The one closest to the river.
This one?
Yeah.
Okay, which I believe is 2. What happens to the pollution when I pump well 2?
Come back.
Taking some of the
Is it?
blue.
Mike, I don't know, is it getting any blue?
I don't know if it's taking
Bring the
anything.
blue up.
Well, the blue is separated by the aquiclude,
Yeah.
so it's really isolated.
So it's kind of coming up.
Of course, this one runs all the way down, so when I pull it, it'll pull the blue up. This one, maybe not. I need, well, this one's very shallow well. Having a little pressure problem here.
Nothing in suction cups. Suction cups. It's rollers.
Yeah, what happened is I got my valve here closed off. It was pinched. All right, so let's see. We'll pump 2 again. Anything going on there?
Red
Bring it
color?
up.
Yeah, there is, maybe, I see green.
It's kind of bringing the blue up, it's bringing the red
I
back.
see the red coming up from like this point.
Maybe so.
Oh, and then I guess writing the green.
All right, so let's pump a shallower well. Now I'm
It's
getting
definitely bringing red.
red real quick. Again, coming down here, I'm gonna get the blue. Here, I get a different. So each depth of well will produce different. Yeah, that was right down into the aquifer, right? So if we take a look at pumping different wells, we can see what happened. I'm going to have to do a little recharge here because I've pulled a little too much water out. So let me put some more water into the system.
This is not, it's too loud.
Yeah, I just got to get the river back up to the right level here. All right, let me take a look and see what's going on. So, wow.
Very sharp.
We could see where we had several reversals of potentiometric pressure. The hydraulic head reversed, the water table changed its slope, basically. And then we saw the pollution go in different directions. We also saw how fast it happened in the open aquifer there, where we have a fractured or a karst area cave system. Notice what happened in the confined aquifer. There was a lot of water in there, but there's not a lot of pollution in there. It's isolated between these two layers that retard the motion of the water. And that's why aquitard means water moving slowly. Okay. The springs got polluted, the wells got polluted. These are artesian wells. You can see the water comes right up to the surface there because of the potentiometric pressure, the hydraulic head. And this all, of course, follows Darcy's law that we were talking about in class the other day, although we didn't spend a lot of time on the math of it. Basically, it just says that if you know your area and the pressure at one end and the other, we can calculate the flow. Well, you have to know the resistance to the pressure going through. So that was the demonstration for this thing. I think it's pretty valuable.
You know, forgot about that.
That's okay. He probably found his way back to the room.
What, I thought it was.
All right, I'm hoping this thing recorded. Maybe it did, maybe it didn't.
That may not have.